If you look at the entire cost of the vehicle, this constitutes almost 35 to 50% of the overall vehicle cost. And then we have the next one is the electric motor that converts the electrical energy into the mechanical energy, which will be supplied to the wheels. And then we have the powertrain for regulating the electrical energy from the battery to all the different components. The key thing that we need to look into this is the price which these components actually constitute in the overall bill of materials. So if you look at the overall lifetime cost, electric vehicles TCO is much lesser than the traditional ICE vehicle. And also with increase in penetration levels and also reduction in the price of raw materials over a period of time because of the volumes, we see this price gonna reduce furthermore drastically, basically making it affordable for everyone. What exactly is an EV? So we all are aware, what exactly is an EV? So, I just put some text as per US Department of Energy. This is pretty self-explanatory. I'll just read through it. So battery-enabled vehicles are a type of electric vehicle which uses chemical energy stored in the rechargeable battery packs with no other secondary source of propulsion. So basically, it runs only on batteries and it doesn't have any other power source like engine or any other fuel to run the vehicle. And it typically uses a electric motor for converting the electrical energy into the mechanical energy for driving the vehicle. We all are aware about the different components of ICE because that's where we have grown from our childhood, looking at all the vehicles out there in the market in terms of petrol, diesel vehicles. But yeah, in terms of EVs, if we look at the key components, unlike the IC, I'll just give a little explanation about the ICE vehicles. So ICE vehicles typically mean internal combustion engine vehicles, which are our petrol and diesel vehicles that have been there traditionally from quite some time. So I'll be using a lot of this terminology ICE vehicle. So whenever I say ICE vehicle, it refers to the petrol and the diesel vehicles. So when compared to the ICE vehicles, there aren't many complicated or complex parts involved in an EV. So the major components that are there in an electric vehicle. So one is the battery pack, which consists of multiple individuals that are put together to form a battery pack which delivers energy for driving the vehicle. And if you look at the entire cost of the vehicle, this constitutes almost 35 to 50% of the overall vehicle cost. And then we have the next one is the electric motor that converts the electrical energy into the mechanical energy, which will be supplied to the wheels. And then we have the powertrain for regulating the electrical energy from the battery to all the different components. The key thing that we need to look into this is the price which these components actually constitute in the overall bill of materials, basically in the overall costing. So battery constitutes almost 35 to 50%, electric motor almost 10%, and then powertrain close to 5%. So these three components put together itself constitute almost 50% to 70% of the overall vehicle cost. Then why EV is actually a fundamental innovation? So like now just we have seen there aren't many complicated or complex systems involved like our petrol and diesel vehicles or the ICE vehicles. Very simple architecture the entire electrical vehicle has. Very small, very few moving parts, which implies that there is no need for setting up a very complex assembly line like typically we have earlier. And also in terms of maintenance, it's pretty low when compared to ICE vehicles. So what does this mean in terms of commercialization? So typically earlier, if we all can recollect IC engine vehicles, so if we look at two-wheeler market, we know there are pretty standard players, 5, 6 big major players we know like whom we are seeing from our childhood, Hero, Honda, TVS, Bajaj. But yeah, Coming to EVs, that is not the case because there are low entry for barriers into setting up a manufacturing plant is less. So with minimal investment, people can actually get into setting up this manufacturing facility of an electric vehicle. So we could see a spike of more than almost 10 to 15x than what we have in the normal IC engine space. And the next important factor to consider is all these electric vehicles are connected by default. So, what do we mean by connected vehicle ecosystem? So, this is the area in which we are actually working upon. So, if you look at the ICE vehicles or the petrol or diesel vehicles, typically, whenever there is an issue in the vehicle, we get a MIL light, malfunction indicator lamp light, in the instrument cluster, or a check engine light. And then we need to kind of take the vehicle to the workshop, and then someone actually connects an OBD tool, onboard diagnostic tool, and then retrieves what is the issue in the vehicle. So it is not actually real time. So the data gets stored in the vehicle in terms of what is the issue, and then once we go to a workshop, some authorized person will come and then kind of check what is the issue in the vehicle. So by connectivity, what we mean is there is a the architecture in itself is very favorable for this connectivity aspect, so wherein we can get a real time information of how the vehicle is performing in the road. So that is what we mean by connected. So also with this specific combination, EVs autonomous driving can be a very a goal which we can see as a closer because of this enhanced connectivity that we see because of the electric vehicles. And then next, last but not the least, we have electric vehicles. Definitely in terms of purchasing one, it's clear than the IC vehicles. But if we see the maintenance part of it or the operational cost part of it, so it is cheap when compared to petrol or diesel vehicles. So generally, if we see, it is almost 0 to 60% costlier to purchase an electric vehicle. And however, the operational costs are 60 to 80% less. So what does this mean? So if you look at a fleet operator where they are heavily reliant on these operations, for them this is a very immediate use case which they can deploy these electric vehicles and reduce their overall operational costs. So that is the reason we also see penetration levels more in this specific B2B segment where they deploy these electric vehicles, reduce their overall operational costs. And also if we see the total cost of ownership, total cost of ownership means over a period of 5 years, considering the life of the vehicle, from the purchase till we are kind of salvaging the vehicle, what is the cost that is incurred. So if you look at the overall lifetime cost, electric vehicles TCO is much lesser than the traditional ICE vehicle. And also with increase in penetration levels and also reduction in the price of raw materials over a period of time because of the volumes, we see this price gonna reduce furthermore drastically, basically making it affordable for everyone. So, just we'll just touch upon who are the key stakeholders in this entire ecosystem. So, right from the start, where it starts from the cell manufacturer who look into what do you say, getting sourcing the raw materials like lithium, cobalt, nickel, and then put it across in a cell, and then they provide this to the battery manufacturers or the vehicle manufacturers. And then we have the battery assemblers who put up this battery pack along integrated with a battery management system module, which is like kind of a heart for this entire system. And then we have the OEMs, original equipment manufacturers, which typically are the major vehicle manufacturers that we see. Like we have Ola. So these are the OEMs that are available there in the market. And the next other important stakeholder is the dealer. So ideally, these OEMs typically sell their vehicles through their dealer network. So this is another important stakeholder in this entire ecosystem. And then we have the charging point operator. Typically, we see a lot of charging points nowadays actually coming up. So these are individual charging points, and the people who are actually setting it up are the charging point operators. And then we have charging network aggregators. So typically, they aggregate all these individual charging point operators and put up an application so that users can easily access all these operators across the city. And then we have the most important other stakeholder is the financier, basically who helps in financing of the vehicle for the end customer. And then of course, last but not the least, we have customer who actually utilizes the vehicle for his day-to-day commute. So there are also new stakeholders that are coming in this specific space as the market is maturing. We see a lot of scope in the recycling part where we have new players emerging. This is just a slide. I'm not kind of supporting any brand over here, but yeah, just to kind of give an understanding. Basically, two-wheelers, typically a scooter, bike, and then a Luna sort of build that we have in the EVs, and then we have three-wheelers. We have different companies already there available in the market. On the four-wheelers, we have, I mean, models that we already see flying on the road: Tata, MG, Hyundai, and then we have buses. We have our own Electra buses based out of Hyderabad, which are actually manufacturing, and then Tata is. Next slide, please. So we have looked at basically what an EV is, what are the different components of an EV, who are the key stakeholders that are actually involved in this entire ecosystem, and the types of EVs. Now let us see, why do we need EV in the first place, and what is actually driving the EV adoption in India. Next slide, please. So basically, if we see in terms of the most important factor that we see over here is the fossil fuel cost. So basically, over the past decade, we can see how the petrol, the diesel prices have actually been increasing. So this is a little past data, but if we see petrol, I believe is a little more than 100 right now, and diesel is somewhere close to 100 per liter. So if we look at the IC engine, the major cost IC vehicle, the petrol diesel vehicle, the major cost is basically the fuel, which the prices are actually increasing on a day-to-day basis. So which directly implies that whoever all are using the IC engine vehicles, their operational cost would directly go up. So that is one of the important driver for someone to shift from ICs to EVs. And the second one is basically there's also a strong government push for ensuring that the electrification is in place. So if we all can recollect in our last budget sessions also, there was this FAME 2 subsidy that was provided to a lot of OEMs out there in the market, so as to reduce their overall overhead costs. So if you see a lot of players in two-wheelers, three-wheelers, four-wheelers, buses, even charging infra operators, charging infra setup people who are actually setting up charging, and they were also kind of benefited with these the FAME 2 subsidy which was provided by the government. So there was almost a subsidy of 10,000 that was provided per kilowatt hour production, per kilowatt hour of the vehicle that is being produced. So this was there for almost the entire last 2 3 years, and then in the recent budget, they have kind of allocated some budget for the specific continuation of FAME 2. But yeah, the utilization is still yet to be confirmed how it's going to be utilized. And also, this is on the supply side where government is providing a lot of production linked incentives, but on the demand side. So basically, if you look at from a customer perspective, what's in it for me? So one, these production linked incentives are also from the OEMs being kind of carry forwarded to the end users by reducing the price of the vehicle. So that is one thing. And the next one is there are certain policies that are kept in place by individual state governments for helping the individual EV buyers. So, for example, in the state of Telangana, the EV policy actually kind of mandated that I believe close to 3 to 5 lakhs of two-wheelers which get first registered will have the registration waive off. So that is some kind of push that was kind of provided from the government of Telangana. Similarly, we have individual states having individual EV policies providing different demand side incentives for the buyers. And there's also loan interest waiver, I believe, where in case if we purchase an EV loan, so we get a tax benefit also over there. So these are some of the perks that were actually provided from the government to ensure that the EV adoption is increasing. So the first graph indicates that when during purchase of vehicle, typically the price of the vehicle is on an average 24% higher than an ICE vehicle. However, if you look at the overall operational cost, it is 60% lower than the IC vehicle. So, on a whole, if we look at the entire total cost of ownership over the life period, it is 22% lower than traditional ICE vehicles. So, definitely, it's a no brainer that people who want to kind of look at these specific aspects, EV would be a much better option. So, the last one is basically the greenhouse emissions impact by internal combustion engine vehicles. So just to give you an example, in 2020, financial year 2020, two-wheelers consumed 60% of India's total petrol consumption. And this resulted in a 38 megatons emission of CO2. And now, if we consider with this statistic, if we consider two different scenarios where we do not have any electric vehicle penetration. However, if we consider another scenario where we have 60% electric two-wheeler penetration by 2030, this would mean a cumulative reduction of 117 megatons of CO2. So basically, we could see the kind of environmental impact which the ICE vehicles have. I mean, when we shift from ICE to EVs, these emissions actually get reduced or neutralized. So that is the other underlying driver for this EV adoption, and we all are aware about the consequences of CO2 emission, global warming, and all that. I don't want to get into that specific aspect. So another slight comparison on the ICE vehicles versus EV. So if you look at the number of moving parts, like we discussed, ICE, the entire internal combustion engine vehicle, the architecture is pretty complex and there are a lot of moving parts when compared to electric vehicle. Energy recuperation, typically the electric vehicles can actually get recharged. So whenever we get the vehicle into charging, so typically the battery gets recharged, and again once it's full, it will deliver the range which it is supposed to deliver. However, unlike in petrol vehicle, we need to fill petrol, so that is the only way out. And then in terms of power density, so basically the power output delivered per weight of the vehicle, so it is more for electric vehicles. And then the torque at standstill, so typically in petrol and diesel vehicles, the torque actually depends on the RPM of the engine. So it attains a peak torque at specific RPM. So ideally on the speed at which we are going, and peak torque is achieved at a specific RPM, and beyond and below that the torque values actually change. However, in electric vehicles, right from the start at standstill, standard torque can actually be achieved, because of which we can see a good pickup in electric vehicles. So next slide, please. So this is just a kind of a representation of the total cost of ownership between the electric vehicles and ICE vehicles. So if we look at the different components of the costing, if we see, so one is the vehicle cost itself, and then we have, like, in case if someone goes for bank loan, there will be an interest cost that will be involved. There will be a down payment, there will be a registration fee, there will be an insurance, and then once we have the vehicle, then there's a maintenance cost typically for running the vehicle. One is the fuel cost, in case of electric vehicle, the charging cost, and then post that, in case if we have to get any normal maintenance work done, so there is another cost involved. And then finally, like, once the vehicle is kind of scrapped, so you get some part of that initial cost that we have. So if you look at both the ICE, for the internal combustion and the electric vehicle, it is almost at par this point in stage. However, if we see the energy cost, basically for the ICE vehicles, that is the maximum, which is basically the petrol and the diesel cost that we put in the electric vehicle. However, for electric vehicles, the energy cost is pretty low when compared to the energy cost of ICE. So what does this mean is that if we can bring down the initial purchase cost and make it affordable to people, the overall total cost of ownership of EVs can be drastically reduced when compared to ICE engines, ICE vehicles.